Good morning. Thank you for the opportunity to speak with you today. My name is Paul Limbrock from the Indiana Soybean Alliance, and I'm here to talk to you about PoreShield, Concrete Durability Enhancer. So I'll speak to you a little bit about the technology and why it may be the best solution for preserving your bridge deck. And then I will go ahead and speak about a program we did in the summer of 2020 with some Indiana counties called the Infrastructure Preservation Program. And then I'll go ahead and turn it over to some of the engineers who took part in that program so that you can hear their firsthand experience with using the product on their bridge decks and the results that they're seeing. So first things first, to understand PoreShield and what makes it different, we need to really think differently. So at first glance, it may look like a lot of the products that you've researched or maybe even used on some of your bridge decks in the past, but it functions in a very different manner that allows it to function for a much longer period of time and provide even better protection than some of the other products on the market. PoreShield is derived from soy, so it's a sustainable technology that's safe for the environment, safe for applicators, and easy to use. But that's not really the focus of this technology. We really need to lead with performance. If you don't have a high-performing product, then the fact that it's sustainable and safe to use is really irrelevant. The third leg of that stool being cost competitive. Obviously, budgets with things like infrastructure can run very tight, and squeezing every penny of service life that we can out of a bridge is very important, especially as we go forward and we're moving into an era of replacing and preserving a lot of our infrastructure. So what's really different about PoreShield? Well, a lot of the technologies that you use that you topically apply to a bridge deck to prevent fluid and ion ingress typically would undergo some sort of a chemical reaction, either a part A and a part B, or a reaction with water or a reaction with air. The goal of those products is to create a coating on the surface that then separates fluid and ions on the surface from the concrete itself. Whereas PoreShield, or SMEPS as it was referred to in research, functions very differently. When applied to the surface of the concrete, it doesn't undergo any chemical reaction. It is actually itself absorbed into the pores of the concrete to create a viscous liquid hydrophobic barrier in the pores. This means that if we treat the entire surface of a bridge deck, for instance, it's going to pull the PoreShield into the pores where it remains throughout its lifespan as a liquid barrier inside the pores that again is hydrophobic. So this will prevent fluid and ion ingress from coming in over time as we apply deicers and things like that to the surface of the concrete. But since it leaves no film on the surface, it won't cause hydrophobic beading effects or make the surface slick or prevent friction or bonding if you'd like to paint over the top of it or come back with a solid coating like an epoxy barrier or anything like that. Another benefit of being liquid and in the pores is that it's self-sealing, meaning that if we've treated an area of our bridge deck and then a crack forms in that area, since PoreShield is liquid and in the pores, the crack through the treated section will re-engage capillary suction. It'll pull PoreShield from the pores in that area into the pores around the crack, providing lasting protection even if some sort of mechanical damage does exist in the section we've treated. It's a really big advantage over products that have that coating on the surface, and once they become damaged, sort of the ball game's over. You've created an access point for the water and fluids, and you're sort of trapping them in. You can really see the benefits of this long-term protection there, those pictures at the top of the slide. The 2 blocks in the middle were treated with PoreShield, and all 4 blocks underwent ASTM C666. You can see the solvent-based silane over time starts to go track with the untreated concrete, just like it has no protection because that barrier on the outside's been deteriorated and it can no longer protect the concrete. Whereas the PoreShield with that liquid internal barrier can adjust and migrate as needed to provide lasting protection. That's where we really get the benefits of PoreShield. When you introduce these deterioration mechanisms and you see rather than providing you 2, 3, 4 years of protection, you're providing 10 plus years of protection with a single application. So again, as I mentioned, PoreShield was referred to as SMEPS in research. That stands for soy methyl ester polystyrene. This was research derived at Purdue University out of a need from the Indiana DOT to provide a more durable pavement joint. Since then, the Indiana Soybean Alliance has taken the trade name PoreShield purely for industry education. It's not a commercially available product you can buy. It is available through several different brand names, through different retailers that the Indiana Soybean Alliance would be happy to connect you to, but we ourselves do not do commercial sales. So when you see the name PoreShield, that's really just to give you something easier to remember and to reference back to rather than SMEPS or soy methyl ester polystyrene. So looking at some of the data from Purdue, we can see that when you look in ideal lab conditions, meaning we've just put the sealant barrier on the sample, there's really been no damage to speak of. So the sealant is exactly to manufacturer specifications and not undergone any detrimental conditions. You can see that the SMEPS or the PoreShield is a little bit outperformed by the solvent-based silane, but both products are keeping the concrete compared to untreated concrete, well below that critical degree of saturation where you're going to have freeze and thaw damage or issues like that starting to begin and snowball. Then when you introduce damage conditions, like I said, whether it be freeze thaw conditions like you see here with ASTM C666, or whether it be salt scaling or just ionic diffusion of ions such as chloride or calcium chloride causing calcium oxychloride formation and things like that, you really start to see the advantages of PoreShield. By having that barrier down in the pores and able to move and migrate to protect new cracking as it forms, you see that the relative elastic modulus of those samples over time is well above the failure threshold, all the way out to 300 cycles, around 90% of the original elastic modulus. Whereas with the solvent-based silane, after 50 to 100 cycles, it starts to track with that untreated concrete because that exterior protection has been damaged, and now water is getting in through the barrier we had created and allowing that damage to perpetrate. Whereas with the PoreShield, obviously we're protecting that for the long term. So in addition to preventing fluid ingress, the Wisconsin DOT sought their own independent study where they evaluated chloride ion penetration. They showed that PoreShield extended the service life of the concrete versus untreated concrete by 5.4 to 9 times, depending on whether or not you were already using fly ash to mitigate some of these issues. But the really exciting data point from this study was showing that when we look 0 to a half an inch below the surface, PoreShield outperformed all of the other products tested, reducing the chloride ion concentration in those regions from that calcium chloride exposure to around 40% reduction. I believe it was 38 to be exact. And then when you go down to half an inch to an inch below the surface, over 60% reduction in chloride ion content there, even given that exposure like you would see with de-icing, for instance. So the deeper we go, even the better protection you're getting from PoreShield because it's actually been absorbed, it's filled the pores with that liquid barrier, and it prevents those ions from penetrating deep into the concrete. And I would add that even though PoreShield was the best performing product in this study, this really isn't even the bread and butter of PoreShield because this was only on a 1-year time frame. And you really expect to see the advantage continue beyond 5, 10, even more years than that. And especially when we have those deleterious conditions, some of those other products are going to start to fall off in performance, whereas we would expect PoreShield's performance in terms of preventing ion ingress to be consistent throughout the life of the product. We've been working with AASHTO groups, including the Innovative Technology Demonstration Group and the National Bridge Deck Preservation Groups. Part of the Innovative Technology Demonstration Group has been approved for a PoreShield field application, large-scale field applications. It'll be 3 applications that'll be tracked and monitored over the first 3 years. One will be a pavement joint project here in Indiana off of I-65 with the Indiana DOT. The second project is going to be a bridge deck treatment in Buchanan County, Iowa. And then the third project will be a vertical surface treatment. We've got quite a few projects lined up potentially for that, but we haven't narrowed it down. So if you and one of your counties have a great vertical surface application where you'd like to protect your concrete from salt or other ion ingress or even just freeze and thaw damage, and you'd like to reach out to us, we'd be happy to consider it for this program. But the basis of the program is that we'll go out and we'll take cores prior to treatment for a reference of the fluid absorption of that concrete. We will treat with PoreShield, and then we will go back and take cores at 6 months, 1 year, 2 years, and 3 years to see the effectiveness of PoreShield and that longevity over time compared to the untreated core we took at the beginning. So this will really go to show the benefits of PoreShield in all these different application areas. And this project will be monitored by an independent consultant. We've actually contracted Indiana LTAP's Pat Connor to be, and Dr. John Haddock to be our independent consultants for this project, where they will be on site, they will monitor the application, they'll receive feedback from the applicators, and then they will be the ones that take in the data and then put all the report together to make sure that the report isn't biased by those of us in the Indiana Soybean Alliance and that there is that independent consultant in the middle, making sure that everything is above board and that what is in the report is actually the feedback from contractors and everything like that. Additionally, here in 2020, as I talked about at the beginning, Indiana Soybean Alliance put together a program that they called the Infrastructure Preservation Program. So this program allowed Indiana counties to plan and submit bridge decks that they would like to apply PoreShield to. The program required them to go ahead and schedule the application, plan it as though they were doing it normally. Then once they've shown to the Indiana Soybean Alliance that they had performed the application, they would be reimbursed for only the material cost of the product. So this allowed them to see firsthand the application process, establish supply channels with the partners who actually sell the product, and see what it's like from start to finish on a job, getting PoreShield on a bridge deck and all of the costs and everything involved. So In total, the project worked with 7 counties to treat 79 bridge decks, totaling over 325,000 square feet. So now I'll turn it over to some of our county engineers and let them tell you what they thought of the project.
It's actually gone a lot better than we had expected. As far as the time frame for being able to apply the product, I came in today originally hoping to get half of the bridges done. Here we are at 10:30 this morning, and we're well on our way to being able to complete all 6 bridges today. This went very, very well. Probably the biggest surprise I had is just the environmental friendliness of it. Like I said, again, not having to worry about inhaling noxious chemicals all day for the guys has been huge, or dealing with burns or anything of that nature. So the fact that we can come out here, if we get a little on us, get a little bit of vapor, it's not harmful, that's a huge benefit. Yeah, I feel like this would, it's going to be actually a long-term positive for the budget. It's going to make the infrastructure last longer, but it justifies its cost in it just alone with the fact that we can go, when we're applying for grants, which is an annual process, and showing that we are maintaining our current assets, we have a plan in place. The investment in this product is going to be more than see its return on investment through that process.
Hello, my name is Carl Anderson. I am Superintendent of Orange County Highway Department. My experience with concrete dates all the way back to when I graduated high school, and even before that. Just to be honest with you, I got an email and didn't really know a whole lot about the product, but I know that we are very lacking in our preservation. And I'm always looking for ways that we could come up with some money to do some preservation. So I definitely went after this grant and was very glad to get it. And I thought if we could start here, maybe this could turn into something bigger for the county and we could keep on with our preservation projects. This bridge was built in 1978. It is approximately a 155-foot span bridge. It is a single span bridge. This bridge is actually located very close to the largest agricultural business that we have in the community. And there is a tremendous amount of truck traffic. Approximately 50 to 60 semis a day cross this bridge, sometimes even more, definitely more during harvest times. We came out and we had a portable pressure washer on a trailer. It took us approximately a day and a half of pressure washing. We got in every little nook and cranny, got it as clean as we could possibly get it, let it dry. And then when we came back for the application, it was a nice, sunny, hot, dry day, and we just did 1/2 of the bridge at a time. One of the main things I like about it is it's environmentally friendly. We can spray this over the creeks, over the waterways, whether it's a dry bed, active water running underneath the bridge, and feel good about if there was, a drip or two to get down into the waterways. It's safe, it's not gonna hurt anything. With the price that it is and for the minimal labor that's involved and the time that I believe we're going to gain on our bridge decks in the future, I think it's going to be a minimal cost and a high reward at the end. It was very fast, very easy, and I actually did it myself. So I was out here and I did the application on it, and I had a couple other guys with me as well, but I was hands-on involved in the application, and I'm here to tell you it's easy. Anybody could do it.
My name is Zach Smith. I'm the Noble County Engineer. I oversee Noble County's Infrastructure Asset Management Program, which includes over 800 miles of roadway and 62 bridges. And then when we were looking specifically at the concrete program, we heard about PoreShield, and it was an excellent candidate for what we were looking for as far as being cost effective and being able to self-install. As we looked at all the various products and we looked at our program, it was focused on bridges that were in good condition, that didn't need some of the deeper treatments, and PoreShield, being a surface sealant, was a perfect fit for our program. So concrete on bridges are very porous, and especially in the northern states where you have winter operations, there's a lot of chloride damage due to our de-icing treatments, which is a contrast to what we do with our asphalt roadways. Joints obviously allow water to run through them, whereas porous surface, water and specifically chlorides can sit there and be saturated over time. This was a historic bridge previous to it being replaced in 2008. It went from a wood plank deck to a concrete deck. And when we were looking at starting a preservation program, we were focused on bridges that were 15 years or newer, that still were in good condition, still had a lot of life left, and our goal was to preserve that life as long as possible. We were really starting at ground zero when it came to concrete protection. Historically, we've had a lot of bridges that were older, and there was no preservation plan in place. So as we looked to the future, we looked at a lot of our newer structures and how to preserve them long term. Obviously, we want a proven product that's been studied, but we also want a product that we can install ourselves without any special licensure. So when we were looking at products, PoreShield met both of our criteria. When we were originally looking at a budget for this year's startup program, we had $50,000. We were thinking that might have been on the low end. We ended up doing 13 structures for under $10,000. So that was the big thing that stood out to me as far as starting a program and having that be a surprise. Our whole program is focused on public service. We obviously maintain our network to provide transportation for everyone. So it's good that we have a cooperative relationship with farmers who obviously use our roads. We in turn can use their product to preserve the roads. I think it's a win-win for everybody. All our bridges are variable lengths, but it doesn't really affect the installation process. We had a two-man crew with in-house equipment, just a single pickup truck and then a sprayer. And they were able to install one lane at a time. Your biggest thing is dry time. The installation goes very quick, regardless of the structure length. Dry time varies based on age and on each individual bridge's attributes, but in general, it took about a day. We looked at the research after we initially had discussions with ISA, which came back great, and then we looked at the pricing, which also came back great, and then the ability to install in-house really made the decision for us. Overall, our program this year was very successful. There were no surprises. We were able to install very easily. The program was very cost effective, and we look forward to continuing the program for several years to come.
So as you heard there from Cole, Carl, and Zach, the infrastructure preservation program in 2020 was quite successful. That's in large part due to that three-legged stool we talked about earlier of high performance, followed by sustainability and cost competitiveness. The performance derived from that ability to limit not only fluid absorption by ionic diffusion, preventing issues such as de-icer deterioration, salt scaling, freeze and thaw damage, but also PoreShield can be applied in low and high temperatures without fear of yellowing or bubbling. It's very easy to clean up just with soap and water, eliminating the need for solvents, and it works on all densities of concrete, old, new, whether it be high performance concrete or high water to cement ratio residential concrete, vertical or horizontal surfaces. It's safe and sustainable, USDA bio certified to be 93% bio-based content. It's low VOC product, meeting the EPA standards for VOC, as well as CARB and the Southern California Air Quality Management Division. Very easy cleanup, like we said, no need for solvents, and the non-toxic profile means no PPE is required, and it's safe for land, air, and water, so there's no concern for small spills or runoffs. Economically, it makes a lot of sense. 0.01% or less of a total project cost, and it's going to buy you 5 times to 9 times the service life versus untreated concrete. And then there's very few added costs. Like we said, no PPE, very easy to apply, and disposal and cleanup is very simple. So very easy to incorporate into the budget, and I hope you'll consider using PoreShield for your applications in the future. If you have any questions or if you think about planning an application, please feel free to reach out to me at the contact information provided here. Thank you for your time. Have a good day.